Hello. This will be a demonstration of proposition 27 of book 6 of Euclid's Elements, which says that of all the parallelograms applied to the same straight line and deficient by a parallelogrammic figure similar and similarly situated to the one on the half, the parallelogram applied to the half and similar to the defect is greatest. It's a bit of a confusing enunciation, but what this is going to look like is we're going to have some straight line A, B, and we're going to bisect it at the point C, so that AC is equal to CB. Next, on CB, which is the half, we're going to describe just any parallelogram. We're going to call it the parallelogram BCDE. And let's just say it looks like that. BCDE. And then, on the other half, AC, we're going to describe the parallelogram AD similar to the parallelogram DB. So, like that. So we have AD, which is similar to the parallelogram described, on the half, namely DB. What we're going to prove is that the parallelogram AD is the greatest of all the parallelograms which can be applied on AB, and deficient by a parallelogrammic figure similar and similarly situated to DB. We're going to begin by picking some point K on CB. Let's just say it's there. And then on KB, we're going to describe the parallelogram BKFH, similar and similarly situated to the parallelogram DB. We can do this by proposition 618. It's going to look something like that. BKFH. And then next, we're going to complete the parallelogram FA by producing FH in this direction all the way out to G. We did that by postulate 2, of course. Now, because DB is similar to FB, right, we made FB similar to DB, and they share a common angle here. We know by proposition 626 they must be about the same diameter, and so we're going to join the straight line DFB. Like that. And again, we know this is going to be a straight line by proposition 626. Now, and we're also going to shoot KF up like this, and we're going to have the gnomon LMO. LMN. Not LMO, LMN. So, we're going to have this gnomon here. Okay. Now, because CF is equal to FE, we know this by proposition 143, that the complements of parallelograms about the same diameter are equal to each other. So the parallelogram CF is equal to the parallelogram FE, which means if we add the parallelogram FB to both of them by common notion 2, these sums will be equal as well, so that the whole parallelogram CH is equal to the whole parallelogram KE. Now, AC being equal to CB, right, we made AC and CB equal to each other. We know by proposition 136 that parallelograms on equal bases and under the same height are equal to each other. And so, AC being equal to CB, we can say that the parallelogram CH is equal to the parallelogram CG. But we had shown in the previous step, step 4, that the parallelogram CH is equal to the parallelogram KE. So by common notion 1, we have two parallelograms which are equal to the same parallelogram, which means they are equal to one another. So that the parallelogram CG is equal to the parallelogram EK. Now, having shown this to be the case, that the parallelogram CG is equal to the parallelogram EK, if we add the parallelogram CF to both, we can say that the parallelogram AF right here is equal to the gnomon LMN. Right, the gnomon LMN is the parallelogram KE plus the parallelogram CF, so it's this whole area right here, and it's equal to the whole parallelogram here, AF. Now, the parallelogram DB being the whole of which the gnomon LMN is only a part, by common notion 5, that the whole is greater than the part, we can say that the parallelogram DB is greater than the nomen LMN, and the parallelogram AD being equal to the parallelogram DB. Again, by 136, these parallelograms AD and DB are in the same parallels, they're under the same height, and they're on equal bases, namely AC and CB respectively. So by 136, the parallelogram AD is equal to the parallelogram DB, which means that because both the parallelogram DB is greater than the nomen LMN, and that the parallelogram AD is equal to the parallelogram DB by a property of magnitude, we can say also that the parallelogram AD is greater than the nomen LMN. But we had shown in the previous step, step 6, that the nomen LMN is equal to the parallelogram AF. And so, again, by a property of magnitudes, we can say that the parallelogram AD is greater than the parallelogram AF. And this is what we set out to prove. We set out to prove that the parallelogram AD is the greatest of all the parallelograms on AB and deficient by a parallelogrammic figure similar to DB. And we've just shown that AD, which is the parallelogram on the half, is greater than some other parallelogram AF, which is deficient by a parallelogrammic figure similar to DB. And we can show this with any parallelogrammic figure we apply to the straight line AB. In all cases, the parallelogram AD will be greater than any of those other parallelograms which are deficient by a figure similar to DB, which means we have proved that which we set out to prove, which means we are done with the proposition, therefore, etc., Q, E, D. You might be asking yourself, what's the point of this proof? And we're going to see immediately in the next prop, 628, why it's necessary. It's a necessary condition on the construction to happen in the next step. So just as like proposition 122 has a restriction placed on it by proposition 120, the next proposition 628 has a restriction placed on it by this proposition 627. So I will move on to the next video, which will be about proposition 628. So on the video here, move on to that proposition 628.